Hi, I'm Niagara, and this is I'm gonna talk about mesh render, and along the way I will talk about grid spawning and a little bit about materials and where you should use mesh render and where you shouldn't use mesh render, right? So everything about mesh render. So without any further ado, let's begin. So for showing you the mesh renderer, let's just go to content drawer, and in here you can see I have a static mesh that I want to use for spawning. Okay, so we will use this static mesh of a curve and we will spawn it with mesh render with Niagara system, right? So it has a material, let's just open that as well, and can see it has a simple material in here, and I will show you how you can use dynamic parameters as well, so bear with me. First of all, let's just go here and create a Niagara system. You know that everybody always start from Niagara emitter, but in this time I want to use just Niagara system. So create an empty system, hit finished. I want to call it NS for Niagara system, and I want to call it code. Okay, I will click on it to open it, or hit enter on it so you can open it. And now in here, for adding a Niagara emitter, right click in here, add an emitter, and in here choose empty, because it is for teaching purposes. We always should use empty, right? If you are watching this video and you haven't watched my videos, my playlist of videos about Niagara system, you should know that there is a playlist of videos that I start from scratch about Niagara system, and along the way we learn a lot. And this time we want to use mesh render. At default, when you create an empty emitter in here, it will add a sprite renderer, but you can delete it and add a mesh renderer. Okay, and with mesh renderer you can use this in here, this static mesh, and spawn it in your Niagara system. Okay, so let's just again go back to our Niagara system in here, and let me explain to you where you should use mesh renderer and when you shouldn't use mesh renderer. If you watch my playlist of videos about Niagara system, you can see we can a lot of cool things with a sprite renderer, but there is a time that you can't have that quality that mesh renderer gives you. But there is a catch to it. When you are using an sprite renderer, every particle has, for example, 4 vertices, okay, or it has 2 triangles. But when you are using a mesh, it has more than 2 triangle, or it has more than 4 vertices. So when you are using a sprite renderer, you can have, for example, 1 million particle in just one Niagara system, and it won't slow down your game, right? But when you are using a mesh renderer, because all the mesh has a lot of vertices, so for example this in here, you can see it has 2500 triangle in here, it has 1,500 vertices, and all of that make your game slower. At some case you should use a sprite renderer if you can get away with that. For example, if you want to create a fire, try your best to create it with a sprite renderer, and if you couldn't reach that quality that you want, use mesh renderer. But know this, when you are using mesh renderer, because every mesh has a lot of triangles and a lot of vertices, it will slow down your game if you spawn a lot of them. Okay, so in this video we will spawn 10,000 of these code, and it won't slow down our game, because we won't add any animation to them, and we won't add any velocity and all of that. We won't do anything like that, because I wanted to show you how you can use this Niagara system to have a static particles that stay at their places, okay, without any movement, right? So first of all, click on this mesh renderer, and in here let's just collapse everything so you can see everything better. Okay, go to mesh rendering, in here go to meshes, and in here you can select a mesh to spawn. You can use multiple one by clicking at this add in here, but for now I'm gonna use just one mesh in here, and the one that I want to use is this code. So let's just drag and drop it in here. No, we have our code, right? So let's just use an emitter spawn so you can see at the spawn rate, and I want to fix the issue and put one in here so we can see just one of them. You can see it clearly, right? So I don't want to do that, so let's just delete it. I don't want to use the spawn rate. And again, in mesh renderer, if you enable material override, you can choose a material for that by clicking in here, and now you have access to the material, and you can use whatever material you want. For example, let's just use this material. Okay, and in that material we can change stuff with our Niagara system. Okay, so now our mesh renderer is set up. Let's just go to emitter update, and in here choose a spawn particle in a grid. Okay, hit fix, and it will fix the problem. And at default it's 10 on X, 10 on Y, and 10 on Z, and you can see it. That's cool, right? So you can see it here, but you can see in grid location that automatically added, we can offset them to each other. Okay, right now they are inside each other, so let's just offset them by 300, for example, on all the axis. Okay, and you can see it. Now we have 1000 code in our Niagara system, and you can see it clearly, right? So let's just again go back to a spawn particle, and what I want to do, I want to say don't spawn anything on Z count. So for example 1, okay, and no, they are in just one row. You can see it, right? So for testing that Niagara system, just go to file, new level, and some of you ask me to where did you find these static meshes that I did talk about in material playlist, and you can see it in here. And if you click it and create one, you can see it here. Okay, they are cool. We did talk about the material on them in material playlist. Okay, let's just go off of that because we have a lot of code we want to add. So let's just add our system here, and now you can see all the code is here, 100 of them, right? So let's just change these to 100, 200, and I want to change the size as well. So let's just go to initialize particle. This time we should go to mesh, or we can just go here on mesh and change the size to uniform, for example, head 3, so they are bigger now. Let's save, and now we can see it here. Now our code, we have a lot of code in here, right? They are cool. So next thing that I'm gonna show you is how you can use material, change the material in here, and how you can randomize that material, right? So for example, we have this material that we open it in here, right? This is the material for our code. So let me show you in here. This is our code. If we put it in here, you can see this is the material for our code. If we want to change the color of this, we can just multiply this surface color, okay, like this, multiply this by a color. So let's just put it here, head hold 3, head leftmost, and you can change the color like this and connect it to here, and with that you can connect it to surface color. Now if you change the color like this, you can see it make it a little bit black. So let's just add this to base color as well, like this, copy and paste it here, and I want to multiply it by this color, and it should be blue. So you can see we have a blue code, right? So how we can change the color from our Niagara system? One way to do it is with particle color, and you can connect this to here and get rid of this and connect these to here as well. So now with particle color we have access to the color of this in our Niagara system. So let's just save this. So for changing the color of these codes in random, what we can do, we can just go to initialize color, and in here in color mode that at default it is on set, click on it, direct set, and in here you can see all of them is white. And for randomize it, if you click on here, choose random range linear color, it will give you an option for given a minimum and maximum, and you can see they are not colorized, they are just between black and white, right? So that the reason for that is that it pick a random value for all the channel together, and if you click in here you can choose to random individual channel, and now you can see we have a lot of color variation in here. Save it, and now you can see we have all of these codes that has cool color, right? There is a lot of them. So you can see at some point it will delete it and create it again. That's because in this particle state you set to kill particle when lifetime has ended. Okay, just deselect this, and after that go to emitter state, change this to self, and in here instead of infinite just choose once. Okay, and if you save this, no, it stay at that color and the color won't change because the particle won't be killed and won't be spawned again. So now we have the army of codes that we use Niagara system to spawn them. Okay, so that was it guys for this video. I hope you liked this video. Please if you want to help me, hit that like button and subscribe to my channel. Thank you very much for watching. Bye.